I think you'll agree with me that once we've performed our subnetting, it would be a really good idea to know how many subnets we have to go around. I think you'll further agree with me, as a matter of fact, I know you will, that it would be a really good idea to determine this kind of thing before you do the subnetting. That would be the best time to apply the skill that you are about to acquire. Now, the best part of this one is that with enough practice, you're going to answer these questions in less than a minute. And you will get to the point where you may not even write anything down on your board to solve this question. And you're thinking, really? And hey, I don't teach tricks. I don't teach interesting octets and magic thises and all that stuff. But really, I'm going to show you two methods on how to do this. One is where we're going to write the masks out because I want you to see what's going on with that. And I'd like you to use that method first if this is new to you, and you'll see exactly what's going on. Then you're going to look at the second method where really it's going to take you less than a minute, sometimes less than 30 seconds. You're going to say, hey, I want that one. But let's not get too far ahead of ourselves here. Here's what a typical number of valid subnets question looks like. You know, how many valid subnets do we have on the 10.0.0/12 network? Or how many valid subnets do we have on the 10.0.0/255.240.0.0 network? Now, I will mention this several times here in the binary section, that these examples, they're asking the exact same question, just in different formats. Now, you're certainly familiar with the standard dotted decimal mask, but what in the world is that thing with a slash? Well, that's prefix notation. It's the much more common way of expressing a subnet mask. Now, the number behind the slash indicates how many consecutive ones there are at the beginning of the mask. Now, the dotted decimal mask 255.240.0.0 converted to decimal is 12 ones, and then the rest of it is all zeros. Now, there are 12 ones at the beginning of the mask. That's where the /12 comes from. So why do we do this to begin with? First off, it's a lot easier to write and to say, because if you're in a meeting or you say, okay, we're going to use a mask of 255, 255, 255, 48, etc., then when you start saying /24 or /30, it does go a lot better. True story, though, there was once a meeting where someone was using prefix notation as they were discussing, subnet masking. Well, we're going to use a /30 here and a /28 here and a /26. And finally, the guy in charge of the network says, well, I don't know what this /24 or /26 stuff is you're using, but here we use masks like 255, 255, 255, 0. So you don't want to be that guy. You want to know that prefix notation, how to convert prefix notation to a dotted decimal mask and reverse that operation. And certainly on your CCNA, CCNA exams and beyond, you should certainly expect to see the mask expressed both ways. Because you could be asked a question, let's just throw this out there. You could be asked a question, what is the subnet that would do this? And it could say choose 2. And you're looking at the choices and just thinking, well, what do you mean choose 2? I mean, there's only one possible subnet that could do this. But they could be expressing it two different ways in your choices. They could be saying, whatever network /8 and then whatever network 255.0.0.0, and they're testing you to make sure that you understand that that is the same mask. So be very comfortable with dotted decimal and prefix notation, as you certainly will be. Now, we're going to get a little practice here, and in print, again, this seems like a long operation, especially at first. But once you're doing it, seriously, you'll be doing this in less than a minute once you're comfortable with the operation. Now, I occasionally see people asking, should I write this chart down? Is this a chart that I should write down before I start my exam? I'm not going to get into when you should write it down. I'm going to get into whether you should be writing it down or not. You should have this information down so cold that you don't have to refer to a chart that you drew on exam day. You should know what the first octets are of A, B, and C networks. You should know what their network masks are, how many network bits there are, and how many host bits there are. This should be second nature. Because, and here's the payoff for that. I'm not just being, I'm not just being Sergeant Foley here and just saying, you got to memorize all this stuff. When you have it down cold like that, you'll be able to use the second method that I show you, and that's where you save time on exam day. So everybody's worried about time. Don't you worry about time, because time comes with knowledge and with practice. It doesn't come because you wrote a lot of stuff down before you hit the start button. It doesn't come because you're writing really fast. It comes when you know your stuff. Okay? That's the key. Everything else, and I'm having to clean up my language here. Everything else is just crap, okay? Just forget all the stuff about, I got to write, 16 pages of information down before I start my exam. No, you don't. But this is something you just got to know this cold. If I show you an address, you shouldn't even have to think to tell me whether it's A, B, or C. And you're going to see what the payoff is for that here in the next few minutes. Because two things we got to remember here. First off, in this kind of question, the subnetting has already been done. We're coming in after the fact, and we've got to tell them now, well, here's how many valid subnets you have. Subnetting always borrows bits from the host bits. Always. We don't get to say always very often in this business. Even if this is the first networking course you've ever taken, you already know that. It's like, well, here's the rule, and here are the 17 exceptions. There are no exceptions to that. Subnetting always borrows from the host bits. So, to determine the number of valid subnets, we've got to know how many subnet bits there are. And looking at this question again, 10.0.0.0/12, we know by looking at the network number, we can see that this is a Class A network. By default, a Class A network mask has 8 network bits and 24 host bits. So that means that someone's already come in and done the subnetting, and we notice by looking at that mask that we have 12 bits set to 1. Well, 8 of them were set to 1 before subnetting, because that's what the Class A network mask is. The first octet is all 1s, and the second, third, and fourth octet all 0s. So that means that someone came in, did some subnetting, and borrowed 4 host bits. That's how we got the subnet mask. Now, once you write it out in binary, and again, do this until you're totally comfortable with it, it's easy to spot the subnet bits, because they're going to be where the subnet mask has 1s and the network mask has 0s. Those are the subnet bits. And I hate that this got off on 2 pages, but that's okay. Because once you know how many subnet bits there are, you just need to put that number into a formula. And I hate to even say formula. That sounds so complicated. It's really not. The number of valid subnets is 2 raised to the power of the number of subnet bits. So we have 4 subnet bits, so we need to raise 2 to the 4th power. Don't be embarrassed to use your fingers. Seriously, I just 2, 4, 8, 16, done. It's 2 times 2 times 2 times 2. You get 16, and that's how many valid subnets you have, and that's all there is to it. Now, that is actually the long way to do this, and that doesn't take very long. But let's look through another example here, and we're not going to draw a chart for that one. Let's say you were given the network 150.10.0.0/21. This is a Class B network, so we know the network mask is /16. The subnet mask is 21/21. Just subtract the network mask number from the subnet mask number, and you have the number of subnet bits. You don't have to draw out a thing. All you got to do here is subtract 16 from 21. That's all there is to it. That gives you your number of subnet bits. It does not give you the number of valid subnets. It gives you the number of subnet bits, and then all you got to do is bring 2 up to that power. So 2 to the 5th power, 32 valid subnets, you're done. And that's where the payoff comes from, by knowing that chart cold. Like I said, I'm not just saying, hey, memorize this stuff for no good reason. You'll be at the point where you're not even thinking about this chart. It's not really memorization until you've practiced so much. Like, oh yeah, begins with 150. I know that's a Class B. That's where you want to be, because that is where you save time on the exam. I don't even want you to have to consider the clock on the exam. I want you to say, man, I finished with 20 minutes, whatever. But that's where knowing that chart comes in handy. It comes in beyond handy. I mean, it really saves you a massive amount of time on the exam. So what I'm going to do now is pause this video for a moment. I'm going to bring up another screen in the next video, and I'll put some practice questions on there, and we'll walk through those, practice a few of them, and then we'll march on to your next skill. See you on the next video.